Welcome to the second talk of the day. We're very thrilled to have Nicole with us virtually. So since Nicole is a true expert in all the areas that we're covering in the workshop. So she's really one of the leading researchers in algorithm game theory, a lot of very important work in market design, and generally on the intersection of economics and computer science. And beyond just her research excellence, Nicole is really like a force of nature in terms of organizing things and keeping our chaotic community under control. And we're very pleased for all her efforts. She's really a force of nature. We're very happy to have her with us. And Nicole, the floor is yours. Thank you.
Thank you. So am I audible to everybody in the physical venue? Some thumbs up or something would be nice. Yeah, great, awesome. I am very happy to be here. I'm from Microsoft Research. I'm based in the Boston lab. And as you can see from my virtual background, a photo was taken a short walk from my office. Boston has by far better weather than Berkeley. So you should all come visit when you get a chance. I did this work jointly with Nika Hagtalab, who is at Berkeley, but I believe traveling at this moment, Brendan Lucier, Marcus Mobius, and Divya Mohan at a time when we were all co-located in Boston pre-pandemic. And so I'm very happy to be talking to you today about this paper. It's called Communicating with Anecdotes. What I want to talk about is a communication game in which we have two players. There's a sender and a receiver, and the sender is going to talk to the receiver about a state of the world, the state of the world. So examples that I'll sort of use as motivation throughout this introduction are politicians being senders that want to talk to their receivers, which could be, say, constituents, about policy decisions that they're making that relate to the state of the world, the state of the economy, maybe, for example. You could imagine that there are, the sender could be a newspaper, the New York Times, perhaps, and the receivers then are the readers of the newspaper, and the newspaper wants to talk about some current events or some newsworthy event that they've researched. And so the key features of the setting I want to think about here is that there's going to be some information asymmetry. That means that the sender knows more than the receiver about the state of the world. So the politicians, the news reporters, they all do a lot of research and go out on listening tours and interviews and whatnot to learn about the state of the world. And then they communicate things about the state of the world to the readers who don't themselves have access to all the information that the sender does. We also have this feature of hard evidence. So this is going to be central to this talk. And I think one of the things that relates it to this workshop, I'm going to assume that the way that the senders communicate to the receivers is in the form of data. And you can think of data in this context as being some factual statement that is not manipulable. And so you can choose what to talk about, but whatever you talk about has to be true. There's no fake news. And another feature I want to model is agency. So the reason this communication is happening is because the receiver gets to take some sort of action, and the sender wants to influence how the receiver acts. And the reason is because the action of the receiver is payoff relevant to both the sender and the receiver. So a little bit more formally, I'll present the formal model later in the talk, but at the moment, I just want to give you a slight more formalization to help me explain the motivating examples. We have the sender, what the sender has access to is, first of all, she has an information structure, which is going to be the signal that she has access to about a payoff relevant state of the world. This is like the research she did about what's happening in the world. And the sender also has a strategic choice to make, and that strategic choice is what to communicate. Something I'll call an object, I'll call a communication scheme, which maps whatever signals she has access to, whatever signals she's received about the state of the world, to some information that she communicates to the receiver. The receiver has also the information structure, but the receiver's information structure is different. She only has access to beliefs about the distribution of the signal in the state of the world. And then she'll receive some communication from the sender and then take a strategic choice, which in the receiver's case is going to be an action that for any communication they receive from the sender specifies an action choice. And the action choice is payoff relevant for both the receiver and the sender. And the way in which, and then, the sender and receiver are going to choose actions, strategies to maximize their utility and expectation over the state and the signal. And I'll get into the exact form, like definition of the equilibrium in the model section of the talk. So the way that the action is impacting this utility is going to be related to the difference between the action and the ideal action of the agent. So the sender has an action that is that she would like the receiver to take, indicated by this blue arrow. And the receiver has an action that could be different from the sender that she would like to take, indicated by the red arrow. And what's important here is that both the sender and receiver's ideal action is simply some shift of the state of the world. So we'll think of the state of the world in the model as being some real number, and the sender might prefer actions that are a bit to the left of the state of the world, and the receiver might prefer actions that are a bit to the right of the state of the world. And so this is like, the high level of what the preferences look like for the agents. And so now with that in mind, let's think through some motivating examples. In one example, we have politicians was one motivating example I mentioned in the first slide. So in this example, we have a sender being a president, and the president, she's going to tell her constituents some anecdotes or some facts about the world. So how does she do that? Well, she has access to a signal about the state of the world, which is research that she's done, by talking maybe to her constituents, or her staff is interviewing constituents. So she has a bunch of signals, stories from constituents related to the state of the world. And then she goes to her speechwriters and says, here's a bunch of facts, write me a speech. And so the process by which the speechwriters sift through those facts and form them into a speech is going to be her communication scheme. And maybe what the receiver that she's talking to could be, for example, employers, and the state of the world is the gender wage gap. So the employers have some belief about the gender wage gap, and the employers are going to take an action, which is how much to pay their employees as a function of their gender. And perhaps the president is valuing fairness over free markets more than the employers do. And so the president wants to sort of convince employers to pay women more, assuming that the gender wage gap is favors men. So the president wants to convince the employers to pay women more. The employers want to pay a fair market wage so that they can compete well in the marketplace. And so their preferences might not be completely aligned. They're just like a little bit shifted from the state of the world. So that's an example in politics. Here's an example in journalism. So in journalism, again, we have the sender being someone with more access to knowledge about the state of the world. Say the New York Times, for example, could be the sender. And the New York Times gets some signals about some state of the world. In this case, let's imagine it's COVID. And so they get these signals because their journalists go out and do a lot of research into COVID. And then they have some editorial policy that suggests what stories they're going to report on and what facts they're going to report in their newspaper. And then the receiver in this case could be the reader, who has her own beliefs about the danger of COVID and the effectiveness of wearing masks. And the action that the reader is going to take is what fraction of time they're going to spend wearing masks, how much they're going to adhere to mask wearing recommendations. And so here again, you could imagine that maybe the newspaper values health over personal freedom more than the readers. And so the newspaper is trying to convince the readers to wear masks more often than they might otherwise if they knew exactly how effective they were. And so the key element of the story I want to tell here is what we call anecdotes. Anecdotes, I want you to think of this as something immutable that you can tell me about, but you can choose whether to tell me about this immutable thing, but you can't change it, right? And so this could be like the New York Times interviews a bunch of people in some city about their experiences with COVID. They can't make up a story from these people. They can just print a story that they hear, but they don't have to print every story they hear. So more formally, the signal that I've mentioned as the sender has access to a signal, I want to think of the signal as being a set of samples or anecdotes that are drawn from a distribution that's correlated with the state of the world. And throughout this talk, I'm going to additionally assume that the sender has access to a signal that is equal to the state of the world. So the sender actually even knows exactly what the state of the world is, but can't communicate that because it's not one of these anecdotes that she has access to. So like I might know precisely how effective mask wearing is because I'm a scientist and I've spent a career building up models and intuitions and like, theories about this, but I can't just tell you that. I have to convince you by sending you facts. This foresight assumption is, we can do away with it in the paper. This is mostly for convenience and cleanliness of the notation in the context of this talk. So here's some examples of anecdotes from those two settings I mentioned of politicians and journalism. Here's an actual quote from a stump speech of Clinton. And this highlighted section here is not actually my highlighting. I pulled this off of a website off of NPR. And what the NPR story was about how Clinton talks a lot in anecdotes in her stump speeches, and she tells lots of anecdotes, and that this is the way that she tries to convince voters of the issues that she thinks are important to the country. And so here's an example off of that NPR website of a stump speech of hers, where she's telling this anecdote about the gender wage gap, where she met two people with the same job, a man and a woman, and they were making different amounts of money for the exact same job. Here's an example from journalism. This is actually the front cover of the New York Times from May 24th, 2020. Probably many of you remember this. It was pretty impactful. It's listing 1,000 people that died of COVID. And the headline, you could think of this as an anecdote that US deaths near 100,000. So these are some examples of where we see anecdotes in the world around us. And so now I want to think about what happens in our world because we communicate in anecdotes. Like what can we conclude about the world if we assume that communication happens in anecdotes? For the purposes of this talk, I'm going to assume that you can communicate only a single anecdote, but you may have access as a sender to many anecdotes. And so the point here is that you get to strategically select which anecdotes to communicate. And then we're going to ask questions about what happens as a result of this. We'll ask what anecdote ends up being communicated. What anecdote does the sender choose? And what we'll see is that the sender is going to, in general, pick a biased anecdote And the reason that she'll be doing this is because she wants to convince the receiver that the state is closer to her ideal point, so that the receiver's action becomes closer to her ideal point. But she also, because her ideal point depends on the state of the world itself, it's a shift from the state of the world, she also has some incentive for accuracy. And so she will try, and there's this tension now between bias and accuracy. She has some incentive to try and give the receiver accurate information about the state of the world. The other thing we're going to look at is, let's think about some parallel worlds where there's, many different senders, and in one universe I can listen to a sender that's pretty similar to me. In another universe I can listen to a sender that's maybe not very similar to me in terms of her preferences, but has a lot more experience and a lot more data to pull from. And so what sorts of worlds would I rather live in as a receiver? Where do I get the most utility? And what we'll see is that there's some tendency towards polarization. So senders with similar ideal points are going to give me anecdotes as a receiver that have less bias, which will make me happier. And so if all holding everything else equal, I'd rather talk to people that are more similar than me, not out of any sort of inherent bias on myself, but simply because I get more information out of those people. Now you could say, well, maybe the people who are experts are not very similar to you. And indeed, if a sender has many, many anecdotes, you could think of that as being some measure of the expertise of the sender. Then even if they're sending me biased anecdotes, it could be that that anecdote gives me more information than a less biased one from a less informed receiver. But it could also go the other way around. And so we'll see an example of that later in the talk. But at this point, you can just think that we'll see through this model that receivers have a tendency to polarize who they listen to, and they have a tendency to seek out experts. So before I get into the model, I want to relate this a little bit to the literature in economics that deals with these sorts of communication games. The one probably most related to our paper is this seminal work of Crawford and Sobel on cheap talk. And so this is a model where the sender can't commit to her communication scheme. So they're playing some sort of Nash Equilibrium style game. And what they see is that it's actually a very interesting paper. I encourage you all to read it. They see that the language in which people choose to communicate has different degrees of granularity, and the more fine-grained languages are an equilibrium when the preferences are more aligned, and therefore we can communicate more effectively when our preferences are more aligned. And we'll see similar kind of intuition in our model as well. The other paper that we relate to is the literature on persuasion. And this is more of a Stackelberg style game. So the sender is able to commit to a particular communication scheme, say like a newspaper with a long-standing tradition has particular editorial policies about what they print, what types of things they print. So if they have access to this type of commitment, then we're in a more of a persuasion style world. This prior literature shows a characterization of the optimal scheme, which includes some pooling, and they sort of say when you have this kind of pooling. And so I probably won't talk much about our game with the persuasion interpretation in this talk, given that I only have an hour, but you can look into the paper for that link. The other sort of strand of literature we relate to is the literature on selection or voluntary disclosure. So here, there's a sender with a bunch of facts, and they can select a subset of those facts to communicate, just like in our game. And the sort of most of the literature here is thinking about a sender being a seller of some good, and the facts that the seller can communicate are related to the quality of the good. And so the seller, no matter what the state of the world is, no matter what the true quality is, the seller wants to convince the buyer that the good is really high quality, because then they'll get a better price. And so the classic work in this area of Grossman, Hart, Milgram, and Roberts shows that you get full unraveling. So the seller, because any news that they don't reveal is perceived as bad news, they'll end up telling you everything about their product. And then there's some more recent literature looking at settings in which this type of result breaks down. Our game is a bit different from these because as I mentioned, the sender in our game has some preference that the receiver has an accurate belief about the state of the world. Okay, so with that background, I'll introduce the model. I have, as I've said, two players in my game, a sender and a receiver. The state of the world, so nature is going to choose a state of the world, theta, and this state of the world I'm going to assume is drawn from a diffuse prior. That is, it's equally likely to be anywhere. The preferences of the agents are ideal shifts from this state of the world. So the preference of the sender is going to be theta plus ms, that would be the sender's ideal action for the receiver to take. And the preference of the receiver would be theta plus mr. And the sender also has access to anecdotes. These anecdotes are going to be drawn from some distribution that's parameterized by the state of the world. So for example, you could just in your talk, in this talk, have in your mind that this distribution is, say, Gaussian with mean theta and variance 1, and there will be n anecdotes drawn from this distribution. So that's the setting. Now, what's the information structure of my game? I'm going to have the ideal shifts of the sender and receiver be common knowledge. Both the sender and receiver are also going to know the number of anecdotes accessible to the sender, n, as well as the class of priors from which they're drawn, so Gaussian, say. And then the sender only is going to have additional information, which is, for the purposes of the talk, the state of the world theta, and the instantiation of these n anecdotes, so the realizations of these n anecdotes, x1 to xn. The strategies are as follows. The sender is going to select a communication scheme, which you can think about as a mapping from the set of anecdotes to a chosen one, such that the chosen anecdote is one that was realized. So for any vector of anecdotes x, I'm going to pick some index I and communicate that index xi to the receiver. The receiver's strategy is going to be an action rule, which is going to be for anything that I've been told by the sender, what action am I going to take? And we think of all of this as living on the real number line. So it's simply a function mapping the received anecdote to an action. And the timing of the game is going to be as follows. You can think of nature first drawing the state of the world from the diffuse prior, and then these anecdotes from the distribution that's parameterized by theta. Then the sender is going to select a communication scheme and pull out whichever anecdote she chooses to send to the receiver. That's going to get communicated to the receiver. The receiver is going to look at the anecdote that they received, pick an action that they're going to take based on their action rule, and then take that chosen action.
Can I ask a question?
Sure.
So is it correct that you draw an entire vector x and then you pick one scalar value and that is your anecdote?
Yes, exactly.
Okay, thank you.
And by you, I guess nature draws this vector x, or you could think, it's drawn from that distribution, so you don't have, you can't influence which x's get realized, but you can influence which x you send. Okay, So this is the timing of the game. And what are the payoffs? And these payoffs are, by the way, exactly the ones from the example section in Crawford Sobel. They can generalize their model a bit, but this is what they work with primarily. It's going to be the mean squared distance between the ideal point and the action for each player. So the sender's utility is, or like the sender's loss is going to be the distance between the action that the receiver took and her ideal point. And the receiver's loss is the distance between the action that she took and her own ideal point. Okay. And so now you can see that this state of the world theta is showing up in the utility function. And if there's a lot of variance over theta, it's going to induce variance in the receiver's action, which is going to harm the sender's utility. So you can start to see this coming into the model here. Okay, so those are the payoffs. What's the solution concept I'm interested in? I'm going to be working with a perfect Bayesian equilibrium. The equilibrium I'm going to characterize and focus on is also a Nash equilibrium, and I think that's a little bit more familiar of a concept to this audience. So if you don't know what a PB is, don't worry about it. Just think of it as a Nash equilibrium. So this is going to be an equilibrium profile of strategies, a communication scheme pi s for the sender and an action rule AR for the receiver, such that each one is a best response to the other. There's also in the paper a discussion of Stackelberg equilibria, and which is sort of the persuasion style set of results, but I won't have time to go over that today. So let's see if we can characterize, I mean, my goal here is to characterize this Nash equilibrium and try to understand what anecdotes are communicated in the Nash equilibrium, and then derive from that some comparative statics. But in order to get there, first I'm going to characterize for you the best response of the sender and receiver. So what do best responses of senders and receivers look like? And what we'll see is that the sender, so this is an informal statement of what I'm going to show you now, which is that when you're communicating with anecdotes, there's going to be yeah?
Could I ask a question? I'm wondering, in the setup that you described seems very sequential, so I can't even make sense of Nash in this setting. Like, could you give an intuition of how would that work? Because there's really an order in the story that you told us. There needs to be like a communication that happens so that the receiver responds. So how can you understand the Nash in the situation?
Yeah, so you can think about the sender is going to choose, so the receiver is going to choose an action that is maximizing their utility given their beliefs. So this expectation here is over the beliefs of the receiver. So actually, so this is why I didn't, this is why I say it's really a PBE. The perfect Bayesian equilibrium is characterized by an equilibrium profile and the beliefs of the receiver. And so the receiver has to be taking a best response in expectation over her beliefs about the state of the world, which are influenced by the communication she received, as well as the distribution from which the anecdotes are drawn, right? And she has to be maximizing this expectation with respect to those beliefs. You can, now you might be a little bit bothered by the fact that I'm asking her to pick an action rule, and that is a function instead of a specific action. But you know, you can ask her to solve this problem for any anecdote she might receive, and then that defines this function. And simultaneously, or I guess sequentially, if you prefer, before she does that, the sender is picking this best response to whatever action rule the receiver is taking. If you prefer, you can also think about them as picking these functions pi and a up front. That I just found in my last talk that bothered people, because like up front, I mean before nature chooses the anecdotes. That would be maybe more comfortable if you want to think about Nash equilibria, but yeah, it's equivalent.
Okay, cool. Thank you.
Yeah.
Hi, Nicole. Just curious. So for the receiver to update the belief, do they need to know the set of available anecdotes?
Yeah, so the entire real number line is the set of available anecdotes.
Oh, but they don't know what are the ones that the sender has.
No.
No. Okay. Thank you.
So if they knew like the set of, so this is sort of the unraveling that happens in Grossman, Hart, Milgram, Roberts line of papers, but I guess I won't get into that in the interest of time, but if you're interested in that sort of, you often see like equilibria of the form, I kind of know what type of information you had access to. So if you didn't tell me about the battery life of the cell phone, I'm going to assume it's pretty bad. But that kind of thing doesn't happen here. So
sorry. So the question is like, is pi s, which is a strategy of the sender, is that like a just mapping from a vector to an index of the vector, or can the sender manipulate his report?
it's a mapping from the vector to an element of the vector. And the sender cannot, so the receiver doesn't know which, like whether it was the like lowest anecdote or the highest anecdote necessarily, right?
Yeah,
so it's not like I tell you this is the second element of my vector is blah. Rather, it's a mapping from a vector to an element of the vector, and I cannot manipulate it. So I have access only to these n points, right? I only have access to these endpoints, the green dots on the slide. And what I'm allowed to do as the sender is from this collection, this set of points or this vector of points, I can pick one of them and tell you about it. Okay, so what we're going to see is that the sender is the types of communication schemes that senders will use in the equilibrium we characterize is they're going to shift the state to some point on the real number lines. They're going to shift it to the left in the settings that I've been drawing on the slides. And then they're going to find the anecdote that's closest to that shifted state and report that one. And what the receiver is going to do is that, well, for any such scheme, there's some bias that the receiver can calculate. So the receiver knows the expected bias of the sender scheme, and she's going to simply try to debias the reported anecdote by shifting it back to the right. And then she'll use that as an unbiased estimator of the state of the world and take the optimal action with that posterior. So that's going to be what the communication looks like. Let's actually write it down. The action rule, I'm going to define a class of action rules that correspond to what I just described informally, which we call translations. So we say an action rule is a translation if for any anecdote I receive, the action I take, if that anecdote gets shifted by delta, is equal to the shifted action plus delta. So I tell you, I tell you something, you take an action. If I tell you something slightly to the right, your action is going to move by that same amount to the right. This is a translation. And one thing to note is that if an action rule is a translation, then there's some constant shift sigma such that the action, you can write that the action rule A of X as X plus sigma. And this is that informal interpretation I was giving you in the previous slide. You can think of this as the receiver is simply debiasing the anecdote by their posterior belief about the bias of the scheme. A communication scheme, so the class of communication schemes that we'll observe in our equilibrium characterization are translation invariant. And what that means is that the if everything that the sender sees gets shifted by delta, then what she chooses to send is also shifted by delta. So if we take the world, we make a copy of it where the state of the world is to the right by delta and all the anecdotes move to the right by delta, then what she chooses to send is also moved to the right by delta. This means that she's not saying things like, this is the anecdote closest to 0, right? Because this absolute number 0 has no meaning in this world. And so this is going to sort of, I think, be a natural class of schemes, given that we have this diffuse prior over the state. It's also without loss of general, like the equilibrium I'm describing is an equilibrium among the class of all action rules and communication schemes. So it's not a restriction, it's just something that falls out of our model. So just to make sure we've understood what a translation invariant communication scheme is, here's some examples. The minimum anecdote is one translation invariant communication scheme. The anecdote closest to the state would be another one. I guess that's not in this picture, actually, the anecdote closest to the state, but yeah. The anecdote closest to some shift of the state, which is going to be the schemes that are going to be in our equilibrium. Those are also translation invariant. And so let me define now this type of scheme. We're going to call it a targeting scheme. A targeting scheme of the sender is going to take the state of the world theta, shift it by some offset tau, and then send the anecdote that's closest to theta plus tau. So another definition that will be useful for thinking about the best responses of the agents is the bias of a communication scheme. And it's natural to think we should worry about the bias because, you know, the receiver wants to understand what theta is so she can pick her action equal to her ideal point. So she's going to try to think about the bias that the sender has and debias whatever communication the sender sends. And this is, I think, also very natural to us when we think about these examples of like the New York Times. We all know it's a slightly to the left newspaper, so we read it with a grain of salt. What do we mean by that? We mean we think about the fact that the facts, we don't, I think most of us doubt the facts of that the New York Times is reporting, but we think about that the facts that they report might be selected to be a little bit on the left, and then update our beliefs accordingly. So here's just an example of what the bias is to make this pictorially apparent, and it's going to become important later. Let's look at these types of communication schemes I've told you will be important, which are these targeting schemes. Then the bias of the targeting scheme is going to be a little bit to the right. So I have this, I've told you to imagine in your head Gaussian distribution. So I guess this isn't drawn very much to look like a Gaussian, but you imagine that there's this Gaussian distribution centered at theta. It means that there's more mass to the right of the target than the left because I shifted off to the left. And so the bias of my scheme, I'm more likely to find an anecdote on the right. And so the bias of the scheme is going to be something between tau and theta, like drawn in the slide. And one thing that will become important here is this gap between this blue arrow and the star. So there's a gap between the offset of the targeting scheme and its bias. So we're now ready. We have the definitions in place of the targeting scheme, the action rules that are translations, the communication schemes that are translation invariant, and the bias of a communication scheme. Those are the ingredients we need to write down the best response of the receiver. And so the lemma is that the best response of the receiver to a translation invariant communication scheme with some particular bias beta is going to be a translation with shift MR minus beta. And this is quite easy to see. You can just write down the utility of the receiver notice that because I've chosen it to be mean squared distance, it's going to be maximized when the action is equal to the shift that I claimed. And so I won't get into the details of this, but I think this is pretty apparent. Am I supposed to end at 3 or my time at noon?
Yes, noon.
Okay.
Noon our time, I guess. Yes. So 3 your time.
So this is, I'm gonna have to speed up a little bit. This is the communicate. You can look at this lemma pictorially. The sender picks an anecdote to communicate. The receiver perceives some bias of this communication scheme, and so shifts that anecdote to the right by that bias, and then makes an additional shift to the right by her offset MR, her shift MR, and that's the action she takes. The sender's best response can be also defined here. And so let's suppose now that the receiver is doing an action of this translation shape, this translation form that I just showed you. What would the receiver do, the sender do, if she knew the receiver was doing that? And what she would do is to pick a communication scheme, so pick an anecdote that is translation invariant. And now the sender, of course, knows the set of anecdotes, and in our talk, at least, the state of the world theta. And so she's trying to do this. She's trying to maximize her utility pointwise. And pointwise, she can do this by picking a anecdote that's ideally, she would love to pick an anecdote that equals the state of the world plus some target that's chosen to make the receiver act as she would like the receiver to act, but she can't pick just an arbitrary real number to send. We've restricted her to pick anecdotes. And so what she has to do is pick the anecdote that's closest to her, what she would want to say. So if she could say anything, she would say theta plus ms minus sigma, but since she can only say anecdotes, she's going to pick the anecdote that's closest to that. And so we call this a communication scheme, a targeting scheme with offset tau. And so now we know that the receiver's best response, the sender's best response is a targeting scheme with offset ms minus sigma, where sigma is the shift that the receiver is going to apply to the communication she receives. So that's now given us enough information to actually write down a fixed point equation that characterizes our equilibrium. And I think it's useful to also go through this exercise of trying to understand what's pulling the sender in different directions. I'm going to skip this in the interest of time, this derivation, but you can equivalently characterize the sender's best response by thinking about sort of rewriting her utility to illuminate the forces that are influencing her in one direction or another that she wants to try and persuade the receiver at the same time as give the receiver some degree of accurate information. So we will skip this. And with the best response lemmas in hand, let's write down what the Nash equilibrium is. That's actually going to be quite easy. We'll be able to write down that the equilibrium scheme is biased. We'll be able to see what the bias looks like, and we'll be able to note that the bias of the scheme grows as and this is the comparative statics part that I'm quite interested in. The bias of the scheme grows as the difference in ideal points, so the sort of preference misalignment between the sender and receiver grows. And also the bias of the scheme grows as the number of anecdotes available to the sender grows. So let's see how that works out. First, remember, I'm going to define something. We've already seen this definition of bias, but I want to make it apparent what what's going to end up being important here is this gap between the target tau, so this blue arrow, and the bias beta, so this yellow star. the gap between the offset tau and the bias beta, one thing to notice about this is that it grows as the target diverges from the state. So if we have a target that's 0, that is, my scheme is, let's send the most representative anecdote, the anecdote closest to the state of the world, then the bias of that scheme is clearly 0, right? Because we have this Gaussian distribution in our heads that's centered at theta, so this scheme has no bias. But as we start to try and find anecdotes that are further and further to the left, the bias of the scheme is going to grow as the target moves further and further to the left. But furthermore, the gap between the bias and the offset grows as the target moves further and further left. And that's because the distribution, the tails get thinner and thinner. And so the anecdotes that I'm finding to send to you are not very close to my target as I go far out in the tail. Does that make sense? So that turns out to be the key quantity that characterizes the equilibria. And another thing to notice, which will be important for the comparative statics, is that the rate at which this gap grows, the gap between the blue arrow and the yellow star, is a function of the number of anecdotes as well, because as I have more and more anecdotes, there'll be more things closer to me even when I'm out in the tail. And so the gap doesn't grow as rapidly as when I have few anecdotes. And so now this gap, this tau minus beta, is the key thing that characterizes the Nash equilibrium. This formula that I've written on the slide falls directly out of the best response characterizations that we saw in the previous section of the talk. And so what it says is that this gap that we discussed on the previous slide must equal the preference misalignment in any equilibrium. And of course, we also have to argue that the equilibrium exists. This is some sort of fixed point equation. So we have to argue that there is a solution, and that's not too hard. First, the characterization follows from the best response dynamics. The solution, the existence, follows from some simple arguments about the monotonicity of this gap as the target diverges from the state. But what I wanted to focus on is that this model helps us understand some comparative statics that might shed light onto how the world operates. So this is the theorem from the previous slide, the characterization of the equilibrium. And there's several observations, 2 observations we can make looking at this. First, let's imagine that the number of anecdotes is fixed, and consider the receiver in a world with different senders, different universes have different senders, right? So every sender has 3 anecdotes, but some senders have an ideal shift MS that's pretty close to MR, and other senders might have an ideal shift that's farther from MR. And because this gap between the target and the bias, that is the left-hand side of the characterization theorem, grows as the target moves further left, that means that the sender that's less aligned with the receiver is going to have a more extreme target, right? So if there's some gap MS minus MR, there's going to be some solution to this equation. And if MS minus MR is larger, the target of the sender is going to shift even further left. So that's one observation. The other observation that we can read directly from this equation is that if we fix this preference misalignment, that is, we fix the right-hand side of this equality, then but we let the number of anecdotes in the world grow, then the offset is going to grow as the number of anecdotes grows. So when we have just 2 anecdotes, I might have to go not so far out in the tail to find a particular gap in expectation between the target tau and the bias beta. But as the number of anecdotes gets very large, because there's going to be many anecdotes close to me even when I'm out in the tail, I have to go much farther out in the tail to get that exact same difference, that exact same gap. So these two comparative statics give us some very interesting implications. First is this observation that extreme anecdotes, so the anecdotes that are far out in the tail, are noisy. And so there's going to be some sort of accuracy loss or signaling loss due to the fact that these anecdotes are noisy. For equal experience levels, that is, if two senders have the same number of anecdotes, then the first comparative static we saw says that the better aligned our preferences are, the less far out in the tail that the sender has to go, right? And so since the receiver wants accuracy, the receiver is going to communicate with a sender who has similar preferences because that's more informative. The other implication, which is maybe a little bit more surprising, is that there could be differing experience levels, right? So this is the second comparative static we're focusing on now. There might be two senders that have different numbers of anecdotes. The one, you could think of this as being experience in that the sender that has access to more anecdotes is more of an expert. And you can think about distributions of the anecdotes such that the receiver prefers to communicate with a less experienced sender who has more similar preferences. So I might, as a listener in the world, seek out people who are like me as opposed to experts because I get more accurate information from the people who are like me. And so an example that demonstrates this is, let's suppose sender one is an expert, that is, they have many anecdotes, but their ideal shift is far from the receivers. Whereas sender two has few anecdotes, but an equal ideal shift. Since the ideal shifts are equal in the second case, the sender is going to send the most representative anecdote. And there's only a few anecdotes, so that every anecdote for sender two is pretty noisy, but they're all centered around the mean of the distribution where there's a lot of mass. And so it might be less noisy than extreme anecdotes if the distribution is heavy-tailed enough. So let me wrap up and then I can take a few questions. We talked about a model of communication with anecdotes, and that inherently is going to result in information loss because I can't tell you exactly the state of the world. I can only tell you about stories that were drawn from a distribution that's correlated with the state of the world. And this kind of information loss, this is the part I didn't cover, but like if the sender could commit, she's going to want to send representative anecdotes because the persuasion bias disappears when she's able to commit to her communication scheme. But this information loss still exists because of the discreteness of what I can say. And with commitment, which is what we saw for most of this talk, the sender is going to pick the, what we didn't see in this talk, I just said that, the sender picks the most representative anecdote. Without commitment, which is what we saw in this talk, the sender is going to pick biased anecdotes, and we can say things about how biased. So fixing the number of anecdotes, the bias that of what the sender says is going to grow with the difference in the ideal shifts, the preference misalignment between her and the receiver. And if we fix that preference misalignment, then the bias of what the sender says is going to grow as the number of anecdotes grows. And this means that for some distributions of anecdotes, the receiver prefers to communicate with less informed senders. And that is sort of a drive towards polarization in society that I think is somewhat novel. And so the open question here that I'm interested in is, like, throughout this entire paper, we are focusing on a setting with one sender and one receiver. I mean, we compare their the utility profiles in different setups, but we always have the receiver doesn't have any choice about who to listen to. But you could imagine a population of people. Maybe initially you could imagine you have a population of senders and a population of receivers, and you could ask about what sorts of clusters form in this world. But even more interesting for me would be if you have, everybody could be both a sender and a receiver, and then you could track how anecdotes travel through the communication network. And so you could say like what people eventually hear this story, and look at that information flow and the resulting beliefs and actions in the society with many agents who both send and receive. So with that, I'll wrap up and take any questions.
Thank you again, Nicole, for your talk.
Hi. I have a question on the thing that you said, but I have also other questions. So on the last thing that you said, where it's you could consider a model where you had agents that can both send and receive informations, could you kind of see that as a market, I'm guessing, because it's really like essentially people are exchanging things, and what you're really like looking for, I guess, is like how, I guess, prices in that market change. Have you ever thought of something like that?
That's an interesting interpretation. I guess here the price is my attention, or
because I'm guessing they're exchanging some ideas, so it's like, the importance of certain ideas, and you could compute that equilibria, like equilibrium prices, and see actually what ideas end up being important or not.
I'm having a little bit of trouble imagining what the price of an idea would be in this model. I mean, there's no money, obviously, but I think you're onto something, which is maybe there's some other element of the model I can associate with a bit of information, maybe like how much it spreads, or its centrality in the final network or something, and associate that with the price.
Because I'm thinking something like maybe like an error to Burr market, where you don't actually have, money, and it's kind of just like the worth of like each of the goods, like kind of like based on to a numeric good. And there it really feels like it's like, what is the relative importance of each idea with respect to each other? So it's like a higher price would denote that, it's an idea that's more listened to by people than others, but I don't know. It's this.
Yeah, it's interesting. I mean, the thing here is like, I don't get to pick what I buy from you, unlike an arrow to bro, right? Like you get to pick what to tell me. So, and you might choose to tell me something different than you choose to tell like Georgios, right?
I see what you're saying. Okay. The other question I have is, in this, I really loved your Nash Equilibrium theorem. Just the implications of it are super cool, like for polarization, like as you get more polarization, I guess things are going to get worse. But I was wondering if you considered feedback loops into this. So, as you're getting more bias, your ideal state of the world also switches. And so that might lead to different changes. So have you considered that? And also, have you ever thought of interventions for this, and like ways to actually get rid of these maybe feedback loops or these negative like polarization effects?
Yeah, so I skipped a part where you could kind of see this feedback loop. I was going to explain how unraveling could happen if we didn't care about the state of the world. Like if I just wanted you to, no matter what the state of the world is, I want your action to be at minus infinity, then this feedback loop just like amplifies and amplifies, and we get the most biased thing in the world. But when we have, so there's this natural attenuation to that kind of feedback loop. There's another kind of feedback loop that you might have been worried about, which is like a repeated game. So I wasn't sure which kind of thing you meant, but that you could also imagine. So this first kind of feedback loop is just sort of happening in our heads. Like I'm thinking about what's my best response to you, given that you're best responding to me, given that I'm best responding to you, and so on and so on. And that unravels what I want to do in a single shot game. But you could also ask about a repeated game. And I guess the sort of extreme assumption you could make in a repeated game is that the sender has a reputation. And so that can kind of be like commitment. And so there you could imagine in the extreme case, I am able to commit to what I'm going to do forevermore. And that I don't like, but I don't know how to do intermediate things. where like we're going to play this for 10 times, right? So that could be an interesting kind of thing to look at. And another reason I like that direction, by the way, is I didn't discuss this motivation for this, but one thing I like to think about is that the sender is myself today and the receiver is myself a year from now. And like I had an experience today, I gave a talk at Simon's, and I need to think about what am I going to remember from this talk, right? And I can't remember like every detail. I can only store one memory in my head. My memory was that like you asked me this question, right? And then a year from today, I'm going to have access, that receiver is going to have access to that fact only.
Yeah. I'm also curious to, I mean, you didn't go over them, but how do the results compare between the Nash and the Stackelberg setting? Like how does sequentiality affect actually the outcome of the prediction?
Yeah, so the Stackelberg setting's pretty cool. Not like technically, I think what I showed you today was very easy. Technically, the Stackelberg one, it's really interesting because if you don't have this foresight about the state of the world, so let's suppose that the sender doesn't know the state of the world either, they just can form a posterior over it, then their posterior is correlated with the anecdotes, right? And so it gets very complicated to think about what the sender wants to send when her, sorry, did I say receiver? I meant sender. The sender sees these anecdotes. She doesn't know the state of the world. She just has a posterior over the state of the world based on the anecdotes she sees. And now her posterior and the anecdotes are themselves correlated. And so this introduces a lot of complications into the equilibrium characterization when she wants to try and commit to what she's going to say. As a result, we can only prove things asymptotically, and asymptotically, as the number of anecdotes grows, we can show that the optimal scheme, we can drive a wedge between the scheme that sends the anecdote closest to the posterior and any other scheme. So like in brief, the answer to your question is asymptotically, the sender will want to send the anecdote closest to her posterior.
Okay. And I promise last question. For your utility functions, you have this square term there, and I'm kind of curious to know if that actually affects by which amount you're gonna get a bias. Like maybe it might induce more a more polarized like outcome, or what do you think? Like if you change your utility functions, would you get different? Like if you had a difference, I guess, distance metric rather than a square one.
This concavity, like, is going to be important, definitely. I would love to prove this result for more general utility functions. What I'm using a lot is that the only thing that we need to worry about is the unbiased, like the posterior mean. And when I move away from this quadratic form, you might care about moments other than the mean. So this is the technical barrier. Okay. I haven't thought about it much more deeply than that.
Cool. Awesome. Thank you very much.
Hi, thank you for your talk. I had a question about, have you thought about maybe applying these ideas to a real data set? Like I was thinking, I think it's probably hard, but maybe you could see the anecdotes as certain items in the newspapers or something, and then you could have multiple receivers, and maybe looking into how quickly people can change their opinions based on the type of newspaper that they read or something. I don't know.
Yeah, I hadn't thought about trying to take this to data, but I guess it does make some pretty testable predictions, like about if we know that, say, in some countries with a, I don't know, sort of government controlled media, maybe you could form estimates of what this preference misalignment between the sender and receiver is in various countries, and try to see if the state controlled media sends more and more extreme things when the citizens are less supportive of the regime, for example. So that would be a prediction of this model. It's pretty hard, I think, because there's so many Like, you know, an experimental economist would be like, but there's so many other explanations you could have had for what caused that.
Okay, thank you.
Yes.
Oh, hi, Nicole. Thanks for the nice talk. So could you say a little bit more about your final open question about have multiple agents? So like, I was thinking about the example you provide, like the newspaper and the mask wearing. So if I'm a receiver, I read some newspapers, I consider that what action can I take, like how much time I wear the mask, but my own decision or my own action seems less sensitive to the sender's utility. It's only like a group of agents move together that are gonna shift the utility of the sender.
Yeah, so I think maybe the first step towards a society with many agents is one sender and many receivers. And then the sender is going to look at the distribution of ideal points of the receivers. And assuming that it's a sort of broadcast mechanism, so the sender has to say the same thing to all the receivers, you could ask, what's a sender facing a distribution of MR is going to say? I think that all of this theory will go through if you replace what I was calling MR with the mean MR in that setting. Now, the next step might be, okay, so now we understand how a sender talks to a distribution of receivers, but what if there are multiple senders? How would they talk? Like, then you have to sort of wonder, does the sender kind of compete with the other senders? So like, does the New York Times compete with the Wall Street Journal and try to steal readership? Or is it simply that like, I just care about the, like, I don't really care about my, as a sender, my utility isn't related to my readership, but rather to the mask wearing in the population overall. And I think that would be the first, like, I don't know how to solve that problem, but that would be my first interesting question is like, let's say there's the New York Times and the Wall Street Journal. They have slightly different preferences over mask wearing, and there's a population of readers. And for any editorial policy or communication scheme of the newspapers, there's going to be some, like, readers are going to listen to one versus the other. And then there's going to be some resulting action in the entire population. So like, should the New York Times move to the right to get more readers so that they wear masks more, but then they won't be able to convince them as well, right? Like, I think, yeah.
Hi, Nicole. Very nice talk. I have a short kind of like technical question. So it seems to me that there's this, you know, there may be zero measure set of games where the sender may have two different best responses. So let's say I have the thing that I would ideally like to communicate, but I have exactly like two symmetric anecdotes, left and right. Okay. And in this case, you know, anything like probably any probability distribution over them somehow is probably a meaningful action for me. Is this something that which could probably complicate the problem from the receiver end? I mean, I guess you can deal away with a small, let's say, regularity assumption, say this is never seen, and I'm okay with that. But I was just wondering, is this something that you thought about, or?
Yeah, this is a very good question. I didn't think about that specific setup because, as you said, I'm not that concerned with sets of measure zero. I do have a suspicion that this is generically unique equilibrium. I did not claim that in this talk because I can't prove it, but it's.
I'm buying it. I'm buying it. Okay. Thank you. Thank you, Nicole. Very interesting talk. And let's all thank Nicole again.